So now we are going to do the example number 7.2, a cam with a minimum radius of okay, so we got the minimum radius this time is 25. This is case number 2. Okay, RPM are given 150, height is given 35, and you know what we already discussed about this height. A minimum radius of 25 mm is to be designed for a knife edge follower with the following data. To raise the follower through 35 mm, so h is 35, during the 60-degree cam rotation. So we have this as a 60-degree. Raise the follower, cam rotation. Okay, we'll see if there's information about this shortly. "60 degrees and then 40 degrees dwell, and then descend to 90 degrees, and then dwell for the rest of this." So we can calculate it, we don't need it to do it now. Draw the cam profile, ascending and descending of the cam with simple harmonic motion. So this is the information we need to know. And this one is going to have, both of them will be simple harmonic motion, which means that when we use the velocity, displacement diagram, we need to use the reference as a circle and take the references out of it. With a simple harmonic, the line of a stroke of the follower is 10 mm offset. So this is about the case number 2. So the case number 1, the follower and the cam profile rotation axis was in the same line. This time the follower and cam profile axis is, rotation axis is little bit offset. How much? 10 mm. Okay, understandable? So how to draw it? We need to have this displacement diagram. Okay, so this is our displacement diagram. We'll use this. We know how to use this displacement diagram now. So let's start with this minimum radius. So what is the minimum radius over here this time? 25. We'll draw this thing with (25). Okay, so this one is RC. This is the location of our follower. Okay. Sorry, offset. So yeah, we'll draw it later on. The location of the follower. So last time everything we measured from this line. Now this is offset by 10. 10, yes. So we draw a circle. How much of this circle offset is x? 10 mm. Okay. And then we draw from here a straight line. Okay. And this there will be our follower. Okay.
So we do a small circle with a diameter with a radius of 10 millimeters.
Yes. Because we need this circle later on. Okay. So we can just do the offset like this, but we need a we need to have a circle later on. Just listen here, and then I'll give you time. Okay. Now we need to do, once you draw the offset circle, we join this point with the point of touching the follower. Okay. So we'll measure all angles from here, this line. Okay, so before that we measured the angle. So I'm just telling you the difference between the case 1 and this case. Here we measured the angle like this. Now this time we'll measure the angle from this black line. Understandable? Okay, so let's draw this thing, 60 degrees. So how much roughly is the 60 degrees something over here? This is over phi A. After that, how much we have? 40 degrees. Okay. After that, how much we have? 90 degrees, something like this. And then rest is the 12. Okay.
Line should be like this.
Which line? All the lines should be like?
Why the 90?
Because it's 90 from here. Okay, because I'm drawing it without any device, so yeah, it will roughly look like this. When you draw it, it will be somewhere over here. Understandable? Okay. Going back to the displacement diagram, we need a reference for the displacement diagram because everything is a simple harmonic motion. We need to divide this. Let's divide it again in the 6 points. Okay. If we divide into 6, 0, 1, 2, 3, 4, 5, and 6. 6 divisions. We have 0, 1, 2, 3, 4, 5, and 6. From here to here, phi A. Okay?
So the minimum divisions is 6.
No, you can even have 5. It's entirely up to you.
4.
4.
Because the angle is small.
Yes, you can have it. But the same number of divisions here, same number of divisions here, and the same, if it is simple harmonic motion, same number of divisions on the circle. Okay? So once we get this extension lines, okay? So we need those extension lines. How we get this extension line this time? So the extension lines are a little bit different. So what we are going to do, the point 0 is 0, but point 1, so for the extension line, for any line, we need 2 points, okay? So last time what was the point? One on the circumference, on the circle, and one was the center. Not this time, it's different. How to do it? It's tangent on this circle, passing through point 1. Tangent on this circle, passing through point 1, okay? And because we assume that we are moving this in this anti-clockwise direction, so the tangent will be from this side, not from here. Okay? So I'll draw this line, start tangent to this circle, passing through the point 1, tangent to this circle, passing through the point 2, tangent to this circle, passing through the point 3, tangent to this circle, passing through the point 4, tangent to this circle, passing through the point 5, tangent to this circle, passing through point 6. Understandable? And this is where the students get really get confused, because they extend this line and these lines are getting at angle, and only practice can make you remove this misunderstanding. All right. Now we come over here. We need to have a reference circle. Okay. Since we have 6 divisions over here, we are going to have 6 divisions over here. 0, 1, 2, 3, 4, 5, 6. Okay, and then we start taking references. Okay, 0 with 0, 1 with 1, 2 with 2, 3 with 3, 4, 5, and 6. So 1 prime, 2 prime, 3, 4, 5, and 6 prime. Okay, we don't need this curve, but just to see how the simple harmonic motion may look like, something like this. Okay, then we need to take the references out of it. All we need to do is to measure it from there. So 0 with 0, this is our first point. 0 with 1, so we get open the compass, because that's the easiest way of doing it. Come on the 1, mark it here, 1 prime. 2, come over here, 2 prime. 3, therefore the labeling is very important, because if you do not label it, you probably give it to second line, and then by the time you reach over here, you already have 5, and you say, where is the 1 line is missing. So this labeling is very important. 3 prime, 4, you open it, 4, 5, and 6. Okay, understandable? So how you transfer these points? From the displacement diagram. Okay, how you take the references? Because this is your job to see what is the input requirement. If it is uniform velocity, then the straight line. If it is not a uniform velocity, then it is not this case. Okay, then we have a dwell. So what in the dwell? This radius will remain same over here, but you do not extend this line, because this is offset. So what you need to do? You need to draw it again. Let me label this point again. This is 6, and this is also 0.6. Why we are calling it 6? Because it's a dwell, and we do not want any change in the radius. Okay, so tangent to this circle, passing to the 0.6, and then you have this 6 prime. So we have 6 again, and this one is delta 1, 6 prime again here. Okay, understandable? It's fairly very simple. If you understand the way the points are transferred, then only issue is just to make a tangent and passing through this point, which is also not a big deal once you start doing it. All right, then we have this phi d. We need to divide it again into 6 division. It's up to you, as I said before. Yes.
Phi A, for example, 6 the phi D also D6 or
No.
can be
The division of this is independent of division of that. Okay. However, since you see, this is the thing you need to see in the planning phase when you're trying to solve this. The second part is also simple harmonic motion. So if you change the number of division, then you need to, this circle should change, or else you draw another semicircle and take the reference from the next division. If you want to use the same circle for this, what you need to do? Same division is the best strategy. But if you want to do it, you can draw the circle on the other side and do this thing, a different division. Or if it is a linear, this circle has nothing to do with it. So you can suddenly change the number of divisions over here. Uniform velocity, then you can change it. All right, so we have 6, 7, 8, 9, 10, 11, and 12. Okay. Again, we need to extend this line before we go to the referencing. Tangent to this circle. My recommendation to you to extend the line only when you want to use it. If you put the extensions in advance, the things would be very different. Okay? Tangent passing through the point 7. Tangent passing through the point 8. Tangent passing through the point 9. Tangent 10. 11. Okay? Now go to the other side and see we have 6, 7, 8, 9, 10, 11, and 12 from here to here. This is very important labeling as well. Otherwise, we don't know where the points are going from here to there. So as a person who is going to review it, cannot do it. All right, because we have 6 division, because it's a simple harmonic motion. So what we are going to do, we'll take the same references. So this 5 will become over here with this line. Okay. This is our 7 prime. 4 will come to this 8. 8 prime. 3 will become to 9. 9 prime. 10 prime. 11 prime. And 12 prime are the same point. If you're curious to see how this would look like, it will look like just like this. Okay. Next thing which we need to do is to transfer these points. So how we are going to transfer these points? 6 to 6, we already have it. 7 to 7 prime, open it, come here, 7 prime, 8 prime, 9 prime, 10, 11, and 12 is on the same point. Understandable? This one is also simple harmonic motion. We are doing 2 possibilities only. There are multiple possibilities, constant acceleration and things like that. We are not doing all these cases, okay? So only 2 possibilities. One is simple harmonic motion, one is uniform velocity. In uniform velocity, we join the point 6 with point 12, we get a straight line. Okay? Once we do this thing, the problem is over. We have get all the information, rest of all is dual, okay? So at the end, what we need to do, we need to join them together. So the shape of something will look like this. This is the cam with the offset follower. Any question?
So when we are connecting these points,
Yes.
but just try to make it.
Yeah, as smooth as possible. As I said before, not like this. Okay, just try to, yeah, you're laughing and I'll show you after the quiz too. And then you'll see it, yeah, you'll see it by yourself. Homework 2 is, by the way, is already available. I sent you the message. Homework 2 is drawing these things. Understandable? Okay. Let's have a 30-second break and then I'll quickly go through it, what we have done, and then we'll call the day. All right, so what we have done, we have a case 2 in which we have a cam radius of 25, minimum radius, knife edge follower with the following data: 60-degree duration for 35 height, and then the 40-degree dwell, and then the 90-degree descending or going down, and then the rest is dwell. Then we have both of these going up and going down, or rise or descent, is simple harmonic motion with the offset of 10 mm. So we draw the minimum radius, RC, we draw the offset radius over here, okay? Then we draw the perpendicular line, which is touching this point. Okay, when we got this point, this is the line of the follower. You can see it is offset 10 mm. And we draw a circle of this 10 mm over here. After that, we join this black color line. You can see this black color line is joining from the center to the offset follower. This is the line from where we measure all the angles. Okay, from here, all the angles are going to measure. So we draw 60 degrees, then 40 degrees, then 90 degrees, and then rest is 12. After that, we have a displacement diagram. Both are simple harmonic motion, so we need to have this circle. We decided to have 6 divisions, so we draw the 6 divisions over here, 6 divisions on the circle, 6 divisions on this side. To extend the line, all you need, because you need 2 points. One is a tangent to this circle and passing through 1, tangent to this circle passing through 2, tangent to this circle from each point, and extend these lines. Then we go here, okay, take the reference from here, 1 to 1, 2 to 2, 3 to 3. Once we got this thing, we get this point 1, transfer all the distances here. And once you transfer all the distances, you got 1 prime, 2 prime, 3 prime, 4, 5, 6 prime. Then there is a dwell. So the same radius, 6 point will get 6 prime again over here. And then again, we have this descent. Okay. In the descent, we can have as many divisions we want, but for a better strategy, if this is 6 division, if you want to change the number of division, for example, the angle is too high, let's say 120 or something, you can still use the 6 division, but if you want to make it more points so that you can join it easily, you can draw another semicircle on the other side and use it as a reference. Here, what we did is we have the same number of divisions, we divide it into 6 times, 6 parts, and then extend them again, tangent, point, tangent, point, tangent. Then come over here, 7, 8, 9, this, take the reference of this, okay? So you take the proper references, draw them over here, back here, and this shape is this red color line, red color curve is the shape of the profile. Understandable? Any question? No question at all? Can you do it? All right, please do it now. I gave you the printout, just make it with your proper instruments.
The use of edge